Welcome to Lesson 4A of the Ecological Design Modeling Series. In this lesson, we're going to simulate numerically the model tank by hand without the aid of a computer so that we can see how the calculations are carried out. Because this is what the computer is doing for us, just doing the same calculations over and over. So this is numerical methods of simulation. So we've taken our tank model and we have an inflow J1 and an outflow J2, and we're saying that J2 equals K2Q. So therefore our equation is dQ dt equals J1 minus K2Q. We're going to solve for dQ, so we're going to multiply through by dt. So we're going to use this in our table. And then we also have, instead of having calibration values on this diagram, we actually have the initial conditions and our coefficient, or constant coefficient, K2. So in this case, the flow in is going to be a constant 5. For ease of operations, we're not going to deal with units at this time. The initial value, meaning the value at time 0, is 100 for Q. So Q sub 0, meaning time equals 0, is 100. So now we can go to our hand-drawn spreadsheet here, and we're going to start at time 0. So at time 0, we know that the flow in is 5. So J1 equals 5. Q is 100. That's what we start with. And we can calculate what would K2Q be at the beginning of time. Well, based on a value of K2 equal 0.003 times 100, which is Q, we're going to get a value of 0.3. Now what's dQ? dQ is J1 minus K2Q times dt. In this case, we're going to assume that dt equals 1 day. Therefore, dq is 5 minus 0.3 times 1, or 4.7. Now this change is what happened on time 0. So what we're going to do on time 1, day 1, we're still going to have an inflow of 5. We need to calculate a new value of Q. And remember that we said that the value of Q at time plus dt is going to equal the time, the previous time step, Qt, plus dQ. And this is the equation that we're going to use to calculate our new value of Q. So it's the previous value, which was 100, which is Qt, plus dQ. So it's 4.7. So this is going to be 100 plus 4.7, which equals 104.7. So we have a new value for Q. Now you can see that this new value for Q is going to be used to calculate our new value for J2. So K2 is constant, so it's still 0.003 times our 104.7. And when we do that, the answer is 0.31. Again, the change in Q, dQ, is J1 minus K2Q, so 5 minus 0.31, and that's going to give us 4.69. So for time 2, we're still got a value of 5 for J1. Add our 4.69 to 104.7, and we're going to get a value of 109.39. And we can keep going through with this calculation. So again, 0.03 times 109.39, that's going to be a value of 0.33. 5 plus 5 minus 0.33 is 4.67. And we can keep doing this, and this is what the spreadsheet software is going to do for us. We're going to set it up so that it looks like this, and we're going to do these calculations and do it for we can do it for 100 time steps, 100 days, 300 days, 600 days, however many days it takes. But what we can start to see here is that J1 was constant, like we said it was, but Q is changing. It's building up, right? It started at 100, now it's almost 10 more units than it was. And we also can see that J2 is increasing ever so slightly, right? It's gone from 0.3 to 0.33 just in 2 days. So there's a pattern of Q increasing because, well, Q is increasing because the inflow is more than the outflow, right? 5 is greater than 0.3. So we're getting a positive increase in Q, but J2 is increasing, therefore it's not increasing by as much each time step. So the first time step it increased the most. By the third time step it's only increased by a little bit less. So in our next lesson we'll do this in Excel in the spreadsheet software.